Hello, my name is Subhasis. Today we'll be talking about uh, for a particular application or microservices that you have developed. Very often you will encounter problems where you might see a lot of your queries are highly unoptimized, or they're taking a lot of time. I'll start a small story. Way back in 2014-15, I was part of a cloud application, and every day when the usage will start and it will reach its peak during the peak usage time, the database will always hit either CPU reaching 100% or memory usage reaching 100%. And this was the story of every day. We'll get into a swarm call, basically waiting for that usage to peak, and uh, figuring out what are the queries which are taking lots of time at the database layer before it actually kind of pushes the database to a state where the whole application becomes in a state not usable by our end users, providing a very, very bad user experience. And during that time, I don't know if that was the problem, what approach you would have taken, right? Now, the context of this application I'm talking about, it was a SaaS application which was already developed. So in either case, you can have a situation where you are developing something from ground up, from scratch, or in a situation, in our case, it was already developed application services. So in case of the first scenario, when you are building something from scratch, normally, the kind of approach you should take is kind of top down, where you don't have any historical records for the previously run queries to look at. So you are building application and services from scratch. You don't have any historical records. You cannot revisit basically what to look at, right? What queries are taking long time and all. You don't have any baseline that is set. On the other side, like you have uh, an existing application or services which are already developed and being used by real users, real end users. So you can go back to your database query logs and take an empirical analysis approach. You can profile the queries which are being run, queries which are run very frequently, like maybe on a daily basis. These are my top 100 queries which are run almost every day. And then you can look at further segregate that into which are the queries which are very costly in terms of which takes very long time, or they put they take use more IO or CPU cycles, or puts pressure on memory network, puts pressure on network data. They're transferring a lot of data over the network. So, and also queries which are fetching either static or semi-static data, right? So all these analyses are very important to take the further course of decisions. With that, now coming back to, let's say you basically are building something which is from ground up, and then with after it has been developed, so at that point what you have clarity is the kind of business use cases for which you are going to develop the services, right, or the application itself, right? So what you can do is you can build the application to a certain level with some inputs coming from your architect, or you just you being an architect, the kind of decisions you take on creating the right structure of the tables, right set of indexes, right set of partitioning strategy. You can revisit that after the system has been put for use by the real users for quite some time, and then you can take the bottom up approach that we have discussed. Let's not spend more time on this, and kind of get to a point where we can do some hands-on stuff. Today we'll focus on doing something on the MySQL database. Okay. So I have just put a couple of very simple SQL queries here in this particular GitHub repository. I'll share this in the description. These are 4 different steps that we'll take today. Creating some sample tables, and then initiating the detection for long running queries. Third step would be running some sample queries, so that it gets into the detection trace or the the log tables, where you can figure out what are the queries which are run very frequently, what are the costlier ones, etc. And then finally, in this particular step 4, we'll complete that, where we'll actually show the queries which are being run frequently. All right. So let's move on. I have my MySQL workbench installed, but I don't have MySQL installed. So we'll just type in, I'm using Mac, use appropriate step based on the operating system that you are using. So brew install MySQL. Takes a while. Okay, now that the installation is completed, let me go to my MySQL workbench and I just rescan the server. It has found one server instance. Let me connect to it. And next thing what we're going to do is, so let me just look at the schemas. There is no other schema other than the sys. I'll pick the query from the step 1. I'll explain what I'm doing. I'm just creating a new schema called tuning. And in that, I'm creating 2 tables. One is called driver locations, another is called products. Okay, and then inserting some sample records in both the tables, and they relate. I have not created the foreign key relationship here, but basically both these tables join via product type column. If I refresh my list of schemas, here you can see those 2 tables. You can browse through. There will be some sample records here, right? So for products. Okay, now moving on, we're done with the first step. Let's move on to the next step, which is initiate the step for detecting long running queries. Okay, I will copy the script. I'll go step by step in this. Okay. One more SQL here, and then let me explain what I'm doing here. So I'm going to create, if this general log and slow log, these 2 tables do not exist under MySQL schema, which is a system schema here. In that, these 2 tables should be created if they don't exist. Next is I'll check certain global variables like general log, log output, slow query log, long query time, and mean examined row limit. These 5 variables, I'll check what are their current states and what should be the right state in order to start detecting the historical queries being run, and then also detecting the slow queries, right? So first thing we should do is, let's run one single thing. So general log, expectedly we just installed the SQL Server MySQL freshly, so obviously by default it is turned off. Same thing would be for the slow query log as well, and rest of the variables you will see some. So it's by default set as file. We'll change this to table, so that instead of logging these queries in the file, we'll start logging them in the database table that will create. Similarly for long query time, so right now by default you'll see it's set as 10, so which is pretty I mean it has to take so much of time in order to be more than this threshold value in order to be detected as a slow query, right? So this ranges from 0 to 10. We will, although this is in second level, so we will kind of use a value that will be much lesser, because we are not going to run very heavy queries during this demonstration. So that way we should be, we should set this particular threshold at a millisecond level, so that any simple queries also will get logged in the slow log table, right? All right, so let's move on. Use MySQL. So let me just check if there is something already existing here. I'll just run a simple query, select start from MySQL dot simple. All right, there is a table already existing, right? So we'll not recreate it. That's not necessary. Instead, what we'll do is we'll just turn this on. General logging, log output to be set as table, global slow query log as 1, and this should be set to a very smaller value, smaller threshold value, so that any simple queries that would be running, that will also be detected in the traced in the slow log table, right? So we have turned on those flags. There is one extra variable which I have not examined, but we can just okay, I can simply run it and show you the value. By default it will be set at 0. Yeah, so that should do that. We did not change anything. Next thing, let's move on to the next step. Would be step 3, where we will run some sample queries based on the tables that we just created, right? Few minutes back. Okay, I'll just run them. The first query is doing something like, based on the product type, how much distance it has traveled for that particular day. And next one, it's just a join between the driver locations and product based on the product type column, right? I'll keep on running a couple of times. Okay, now let's go to the step 4. I might have to change a little bit. Those queries are based on my other schema that existed in a previous run. So you can see it has started detecting all those queries which are run. Let me also check the slow queries. So if I just run this part alone, yeah, you can see they're being captured here, right? So if you just run this query, right, so how much time it has taken, so you can see those things over here, right? Execution time 0.0009, and the threshold that we set here was 0.00001. So obviously it is more than the threshold value, right? The execution time was more than the threshold value. That's why it has been detected in the slow query list, right? And same thing, if I just run this one, you would see how much time it takes, and is it more than the threshold value or not, right? So you see the query stats here. It has taken 0.0019. All right, so now let's do one thing out of curiosity. So now that you have seen they are being traced under the slow queries, so let me just clean those two tables quickly, very quickly. So I have got the distinct queries here. You can see select distinct star, or without distinct, select a dot star, b dot star. So those queries that we have run here, a dot star, b dot star, and If you want to see the whole query, you can just do like this text. See, this is the query that we have run here, right? Now let me clear these logs. Let's say truncate. Don't do drop table. Okay, be very careful with that. These are system tables, so you should also it might not let you. Let me just show you. It might not let you truncate the table because the flag is turned on right now. So when the flag is turned on, it won't let you. Okay, it actually let you clean, but if you try to drop it, it will not let you drop it. Okay, so let's see if we have anything left here. No, we don't have anything. It is just the truncate query alone has come into the slow log. Now what I'll do is I'll increase that threshold value a little bit. Okay, so maybe I'll put it as 0. Right, let's do this. So now I have a higher threshold. So queries which are taking more than this, they will be recorded in the slow query log. So let's run these queries once again and see how much time it has taken. It is not more than that threshold value. So now if I come and query here, you'll not see that here, right? You can see that. You'll not see that. In fact, if you just use the filter, that will be much cleaner rather. Now let's run the slightly costlier query here, which is hopefully it is going to be more than the threshold value, 0.0010. Hopefully it might now come here. Let's see. Oh, it's still not. Okay, so run a couple of times. 0.002 and our threshold was 0.001. Okay, you can see, there you go. Okay, you can just filter for the driver text in the query and you can see. Okay. Now let me run the other smaller query, which is not going to exceed the threshold value, right? It's much lesser than that. And next time you check the slow query log, you'll not see that. However, if you see in the general log, we did not truncate it. Let's truncate that quickly. Table MySQL dot general log. Okay, now the table should be empty. Yeah, so let's run this query a couple of times and see if you have found something here. A lot of them. Okay, all right. You get to see the system queries also, but if you just run this one, that should do it. Okay, there you go. So it comes in the historical query run list, but if you check that in the slow query log table, you'll not get that. Okay, so that is what I wanted to share. There is just one thing I wanted to mention before I kind of wrap up this one. If I do select star from, right, if I run this, you will see the query is this particular column called argument, which is capturing the actual query text. That is shown as simple blob, and that's the reason we are converting that to string using UTF-8 encoding. Okay, with that I'll stop this. Please provide any questions or comments in the video. Thanks.